or I can go horizontal. Horizontal is I buy more machines. Hence the terminology as vertical and horizontal. Now, if I go and get 100 laptops, the problem is maintaining those 100 laptops, right? Like which laptop is working, which laptop is not working. When the user has to talk to me, then which laptop should the user talk to? Which is what is the IP address that is present in DNS? Like which laptop's IP is that? Then what happens? Let's say if suddenly one of the laptop reboots or restarts. What happens when like one of the laptop becomes slow? All of that becomes a large issue that I need to handle. What happens, let's say if one of the laptop has an issue with the RAM, I'll have to replace it, etc., etc., right? Managing these many number of machines, by the way, like managing these machines myself was called as having an on-premise data center. This is what a lot of companies would do long back. So if you look at office structures of a lot of companies, you would find that in early days there used to be this one large room that every company had where they would stack a lot of machines, and that's where their server room or data center everybody had their own local data center, which where they would have these machines, and uh, through these machines they were serving traffic, right? However, managing these many number of machines themselves is, like very cumbersome. Like, you have to monitor every machine. You might need, suddenly you might realize, oh wait, oh these machines are very primitive. I need a better CPU, I need better RAM. Then I mean, you can't throw away these machines. Getting now new machines will cost you a lot of money. So because of all of this, people started to realize, oh wait, managing machines myself is a very cumbersome job, right? So what started to happen then was, and Amazon was the almost the first person to do, first company to do it massively, was Amazon said, look, you guys are all small players. I have huge data centers, right? I have these data centers where I have roughly like 10,000, 100,000 machines. Imagine, hypothetically, I have 100,000 machines here, all kinds of machines, right? Um, Racks of computers. In fact, let me share an image of a data center. If you open this article, then you'll find an image. This is what a data center might look like. So Amazon said, look, I have these many number of machines. I am not using all the machines all the time anyway. It is costing me a lot of money. Why don't I do one thing? Why don't I start getting these companies and saying, why don't you obviously find it very hard to uh, maintain machines yourself. You rent machines from me. Why don't you say that, look, here are 4 machines that I want. Please give me access to these 4 machines. I will run my stuff using those 4 machines. Now, making sure these 4 machines are running, etc., is your responsibility. Correct? Making sure that these are running is your responsibility. You manage it for me. I will pay you slightly more money for this. So I am renting it from you. I am sort of leasing it from you. Shaktiraj, yes. I mean, there are these kind of cloud companies in India as well. For example, MediaOcean is another company, right? So it does very similar kind of thing. So this is what is cloud, which is I don't own these machines. There are these large farm of machines. Like there's a large data center. I go and rent some of the machines from there. There are so many details that I haven't touched on, which I will touch on in just a small period of time. But on a very high level, data center cloud has nothing to do with the cloud that you see in the sky. Cloud is, there is a large data center of machines where anybody can go and start renting machines from without having to know like what those machines are like. You specify your specification, what kind of machines you want, how many do you want. You can keep asking for more machines. completely fine. Maybe you use 10 machines for 1 hour and then next hour you just use 2 machines. That's fine. You pay me by the hour. You pay me for the number of machines into the amount of time that you use it, right? Just like, for example, imagine, let's say you have to visit Mumbai very often, once a month. Now, there are two options with you. You maintain your own house, your own food, etc., etc., or you go and rent a room which is ready made in a hotel. This is exactly like staying in a hotel. I am able to rent something from a hotel, right? Like, I don't want to maintain this entire house with um, with all the grocery and everything. I mean, everything is provided to me here. Now here, this is the basic concept of a cloud. Now here there are three layers that come, three layers of cloud that come, which are roughly as called as infrastructure as a service, platform as a service, and software as a service. I'll explain all of them slowly, one by one, right? My one use case would be, if I'm a Manish, serverless is different. I'll come to the serverless part as well. It is their part of the session today. So one part of um, my requirement could be that, look, I know how to manage machines. I have my code base. I will, if you give me machines, I will install the right kind of operating system on it, which is, let's say I want to run something on Ubuntu. So I'll install Ubuntu operating system on it. I will install the right kind of, let's say, whatever software is required on it. I will run my Python code on it, and it runs, right? So basically, you give me infrastructure. You give me infrastructure. I don't need software platform. If you give me infrastructure, which is, if I tell you, give me 4 machines, maybe these machines should have 8 GB RAM. Maybe they should have 250 GB hard disk, and maybe they have some, let's say, 1.6 gigahertz CPU, right? So give me these kind of machines. I will manage everything myself after that, right? When you do that, then you are basically essentially doing infrastructure as a service, right? So every cloud provider that you hear of, which is AWS, Azure, Google Cloud, a lot of these cloud providers do exactly this. You can go to an AWS and say that here are the kind of machines that I need. How they do so internally, that I will explain, Srikar. That's where VMware will come. But I'll explain once more, Shivansh, right? Imagine that, Shivansh, you're running your own company, correct? In your own company, imagine, let's say you built your own version of Flipkart. Now, when you're running Flipkart, you realize today, for the kind of traffic that I get, I want 4 machines where I can run my code. And when a request comes, I want to send the request to one of these 4 machines. Right? So you require 4 machines right now. You know the kind of machines that you need. So you go to AWS, you say, hey, here is the configuration of machines that I need. Please give me these 4 machines. I will actually copy over my code to these machines, and I will run these machines. The auto scaling, Terraform, I'll come to that. Let's go step by step, because other people will get confused then, right? So I can say that, right? Now imagine your traffic increases. Then you can tell AWS that, oh wait, I had asked you for 4 machines. Now I need 8 machines, exactly like this, right? So AWS, or let's say Azure or Google Cloud, can increase the number of machines from 4 to 8. If later on you ask for 12, they can increase it. If you say that, wait, I don't need 12 anymore, I just want 8 again, they'll do that. And they will charge you for the amount of time you rent these machines. So essentially, you're just asking for machines on rent, right? That is infrastructure as a service, which is, you give me machines once I tell you the configuration of the machines. There is, however, a second higher layer, right? You could say, hey, why do I want to control machines? I know, I mean, let somebody else handle what operating system to install. I know that my code is in Python. My code is running Django. So all I want is, I don't want to control what number of machines, etc., right? I want to go and tell somebody, I have this Python Django code. Can you let me put this on whatever machine you have, right? Okay, what is Django? So when you build a project in any code base, you can use any programming language that you want. So Python, Java, Ruby, all of these are uh, programming languages. Now, these programming languages also have a framework that makes building project easy. So for example, Python has Django, Java has Spring Boot, Ruby has Ruby on Rails. So different languages have different framework, right? Now imagine I have built some project in Python using Django. I want, I don't want to take the headache of these machines, etc. Right? Somebody else handle that. I just want to say that I have this Python project. Please, please take my Python project. Please, please do whatever you want to do with the machine. Make it work. Right? If I want to say that, then I want a platform as a service. Now here the examples are: you have Heroku app, or you have Fly.io. There you don't need to get to the details of the machine. You can say, I want a Node.js environment, or I want a Python kind of environment. Just here is my project. I upload my project. It starts running on your machine, and anybody can then access my website. That is called as platform as a service, right? I'm not dealing with machines anymore. The last bit is SaaS. I think this is something that all of you would have used, which is, you say, I don't even want to build a project. For example, you might have used Slack or Teams, right? Which is, there is a software in the cloud. There's a software in the cloud. All I am doing is I am creating an account there, and I'm just going and using it for my company. So Slack that you use for your company is exactly SaaS, correct? Um, I see that some of you are asking me to repeat PaaS. I will repeat PaaS again. SaaS is clear. SaaS is clear. Like almost all uh, things that you use inside your company, right? All software that you use inside your company is SaaS. Zoom is, for example, also SaaS. Your Discord is SaaS. Your Slack is SaaS. If you use like Fresh Chat or things like those at your company, that is also SaaS. SaaS is clear to everybody. Teams is SaaS, yes. So essentially, all of these are software that are running on the cloud instead of me having to build a Slack. I mean, imagine, let's say somebody comes and tells you, hey, Anshuman, I want you to set up a chat system for the company. Now, you could decide that I will go and rent machines from Amazon. I will build a project where people can do chatting, right? Or you could say, why do I need to do all of this? Let me go and find a software like Slack. And what I will do is I'll set up everybody's account on Slack, right? So that way, what I've done is I'm not renting machines anymore. I have rented a software. Now, making sure that this software is running on the cloud, on those machines, that is Slack's responsibility. They will do it. They'll make sure it is working. I am just using the software, right? So that is SaaS. SaaS clear to everybody, and infrastructure as a service clear to everybody. Is that the right? I know PaaS is not clear to some. I will explain PaaS, but SaaS is clear. And infrastructure as a service is clear. Okay. All right. Let me explain infrastructure as a service versus PaaS once more. Imagine hypothetically the same delicious example, right? You have to write, folks, just pay attention. You have to write some code, right? Imagine, let's say I build this Python project which takes in user ID, takes the bookmark, and it saves in a DB. There is a, let's say, MySQL DB here. It saves it here, correct? So it's a basic Python project. Now there are two ways I can deploy this project. There are two ways I can put this project on cloud, which is rented machine, right? One is I go to AWS. I say, look, give me a machine, give me 2 machines or 3 machines, whatever it is. I want machines, let's say, which have good RAM. So let's say they have 8 GB RAM. I want machines that have good hard disk. They have good CPU. Give me these machines. What I will do is, whatever code I have written, whatever is my code base, right? I will copy my code here. I will copy my code here. Maybe to run my code, I need to install, maybe I need to install Python 3. I need to install certain libraries so that my code runs properly, right? Maybe let's say I want to install some MySQL client as well, right? Python is a language. So how do you run Python on your machine? You install Python 3 is the third version of Python. So you install Python on your laptop, right? That's how you run it, right? So this is nothing but like your own laptop, but it is sitting somewhere else. So you go on your laptop, you log in into your laptop remotely, and then you install the right things there, right? And then you put your code there, and then you run the code. If something is not working, then you can go to the machine and check what is not working. Maybe it is a problem with the machine, maybe it is a problem with my application, something is wrong, right? Doing this is infrastructure as a service, where I am not asking AWS for any help. I'm just saying, give me the machines, I'll manage everything myself. However, the other way of deployment could be that I could say, look, I don't want to handle all of this. I have this Python project. I have this Python project. Imagine I go to fly.io, right? I tell fly.io, I have a Python project. So give me a Python environment. So whatever is to be installed for that, you are responsible for that. Make sure you install it. In your Python environment, I will upload my project. And RDS is sort of like a pass. Yes, because you get MySQL pre-installed there, right? So no, GitHub is not pass. GitHub is SaaS. GitHub is SaaS, Anurag, because GitHub is a software that you get and you can directly use it. But if I go to fly.io, I can say, here is my project. Please upload the project and now start running it. I can, fly.io is a website, or Heroku app is, for example, a website, right? So I could say, hey, here is a project. I can then click on run, and the project runs. It generates some kind of URL, some kind of link, which anybody can use to access my project, right? So if you see, a lot of the work that I would have had to do goes away. So that is PaaS, which is one layer above SaaS. Anyhow, if PaaS doesn't make sense to you, don't worry. I mean, it's not a deal breaker. It's not a deal breaker. We'll come to that later. But roughly, what is infrastructure as a service, platform as a service, and software as a service? Does roughly that make sense? Infrastructure as a service is nothing but where you ask somebody to give you machines on rent. Infrastructure is nothing but the collection of machines and network which connects those machines, right? Okay, moving on, just to make sure that we're keeping everybody along. Now, this is basic introduction of cloud. I'll come to VMware. VMware is something that all clouds use to get something done. Now, this is how I would use as a user. Now you have to start thinking also about the cloud machines, right? Which is, let's say, I think about AWS. AWS would say, look, I have built this entire thing with high quality machines, but there are people who come to me and say that I don't need high quality machine. I only need 2 GB RAM. Now, where do I go and get a machine which has only 2 GB RAM? So hence, because clouds can't go and buy you bad machines. So cloud, or essentially your AWS or Azure, what they say is, we rely on something called as virtual machines. Virtual machines and hypervisor. I'll explain what those are very, very shortly. So imagine I am Amazon, right? I have a lot of these machines, very high end, very high quality machines, right? Kamal, yes, yes, okay, okay. One other thing which I just want to set as an expectation today, I am not going to be building anything on cloud. So if you, I mean, just setting the expectation correctly, I am not going to be deploying anything on cloud, or like, let's say, build an e-commerce website on cloud. That is not the purpose of this session. The purpose of this session is to introduce cloud to you and introduce how to go about learning cloud in the future. What are the aspects that are important, and how should you think about cloud, right? Is that okay with everybody? Like, we're not building anything on cloud right now. We're just building the concept right now. The purpose of this session is to enable you to go and learn cloud yourself later on. Fundamentals of cloud, right? Okay. Because the thing, look, I mean, if I start writing code here and show you that, you'll start to feel that, I mean, that's something you can also Google and learn. But getting your understanding correct, that's the part which you can't Google. Hence, I'm trying to cover that in a class. Okay. So let's first understand how does AWS work. What do they do behind the scene, right? Now imagine AWS has a lot of big machines. Imagine these have like 256 GB RAM, very high end machine, right? Like this has, imagine 5 terabyte hard disk. It has, let's say, 4 gigahertz CPU, very very high end machine, and it has a lot of these high end machines. Now imagine there are two users that come. Imagine Adarsh comes to Amazon and says, "Hey Amazon, I need a very small machine. I don't have a lot of money, so I need two machines, because obviously, like, large machines are also going to cost you a lot. So I for my job, I don't need a very very large machine. What I'm going to do is I'm going to ask and say that, hey Amazon, can you give me two machines that have, let's say, 2 GB RAM, 2 GB RAM, 2 GB RAM, maybe only 100 GB hard disk, and maybe some other parameters, right? Now, how does Amazon do that? Because all of these are large machines. If I give two of these machines to others, while others wanted less, so I'll be able to charge others very less amount of money, while others is completely using two big machines without actually needing the entire machines, right? So what can I do? So there was born the concept of virtual machines. Virtual machines are nothing but saying that I have this large machine. What if I create form of machines inside, or imagine, let's say, I create some form of boundaries. I say that, look, there is going to be a machine one inside and a machine two inside. These are not real machines, but these are virtual machines. Just think of it conceptually, where this machine one can only use, imagine, half of the CPU. Whenever it starts to go beyond half of the CPU, then it is restricted. Very similarly, you can only use half of the RAM. It can only use half of the hard disk, right? So it's so I can create two parallel machines, and I can restrict each of these machines on how much resources they can use. I can also make sure that they are protected, which means this machine cannot access data from here, and vice versa. They're also excluded in some ways, isolated in some ways. Thank you, Himanshu. If I can do that, then it will make my work very easy, right? And like, this is basically what a lot of companies started doing. For example, VMware was one of the company that started by building virtual machines, and then they made hypervisor, etc. Very similarly, Citrix also does that to some extent, but they do what is called as virtualization. Virtualization is nothing but I create these imaginary partitions where this one partition can only use some portion of CPU, some portion of RAM, and some portion of the hard disk. That way, while I have this one machine, but I can create inside this machine four small machines. So if somebody comes and asks me for a small machine, I can allocate this partition to them. They don't get the entire machine, but they get this partition. Whereas maybe there is another user. Maybe Suraj comes to me and says, I also want a small machine. Suraj gets this partition. So both Suraj and others are working on the same machine. I have increased my utilization, right? And on top of this, on top of this virtual machine, I need somebody who's monitoring that these virtual machines are working properly. If something happens, then is there a way to recover? And to do that, there is a process called as hypervisor, which was also, by the way, built by VMware. Docker is how do you configure a virtual machine, right? It's a easy way of configuring virtual machine. I'll come to Docker as well. We'll go step by step. We'll go step by step. So hypervisor is think of it as a software. Think of it as a software. All it does is, now within a hypervisor knows that this machine has four virtual machines. It has four virtual machines. So I am monitoring whether these four virtual machines are working properly or not. If something happens to them, if something happens to this virtual machine, then there is, let's say, some action that I take. Maybe I reallocate Suraj to another virtual machine, or maybe I create another virtual machine, etc. Whatever is required. That all of this is being managed by hypervisor, right? So it's a process that is running, that is supposed to be the master process, monitoring and managing. There, so hypervisor actually, there are two kinds of hypervisors. It works on bare metal as well, and there is a type 2 hypervisor, which is which is I forget the name for it, but it isn't bare metal. But forget about what I said about bare metal. Forget, there is nothing called bare metal. Folks, there is nothing called bare metal. We are jumping, so please forget about there was any mention of bare metal. We will go slowly through the terminologies. We'll not jump through terminologies. Okay. So, do you understand why was there a need for virtual machines? Like in the context of cloud, why was there a need for virtual machine, right? Because people come and ask for different configuration of machines, right? I could say I don't need a very large machine. I don't want to pay so much money. Hence, I want a small machine. But Amazon cannot produce a small machine. So Amazon said, look, I have large machines. What I'll do is I'll split it into different parts. Some of those would be small machines, right? And you use your own part. Your part will not be affected by the other parts, right? So it's just that, imagine, let's say I have four virtual machines here. If somebody is running a very heavy process here, they will not be able to impact these virtual machines. That guarantee I take. And that's the concept of virtual machines. This is also called virtualization, yes. Right? So that's why virtualization was born. That's why virtual machines were born. And hypervisor is nothing but just a monitor of those virtual machines. Now let's move on to, I mean, this is just a minor thing just to help maybe set in context how do cloud work. But let's now get to the same thing, that I am the owner of Delicious. I had started facing problem. I had realized I cannot handle these many machines. Let's go back, take us back to the story where we were running Delicious. What happens when we move Delicious to cloud? What are the other kind of use cases that may come across, and how do you solve those use cases? We'll go to that. Till now, is everything making sense? Okay, hypervisor runs on the same machine. If the machine dies, then all your virtual machines are dead. So, which is like on that machine, if there were four virtual machines, all those virtual machines would be dead. There is also a high level monitor saying that if others has asked for two machines, if one of the machine is dead, then I will allocate some other machine to others, which is some other virtual machine from some other machine. Which machine does this come in? Is it coming from? Others need not care about that. It is hidden from others. Okay, let's go back to our story. So I was introduced to this concept of cloud computing. Somebody told me that, hey, look, AWS is giving you machines on rent. Um, your all of your headache would be gone. Why don't you go and rent machines from AWS? And I was like, oh, great, this is a great idea. Why do I need to go and buy 100 laptops from the market? Let me go rent machines from AWS. So I end up getting a bunch of machines. What is Delicious? Okay, folks, did you join late? Delicious is this website that we had started with, bookmarking website, the entire start of the story. Okay, so for now, I mean, just assume that it's a website. It's a bookmarking website. It stores your bookmarks. That's what it does. We had to look at cloud because it was growing massively and we were running out of space, CPU, etc. And hence we said let's go to multiple machines, and that's when we came across cloud. So okay, fine. I come to AWS. I say, hey, AWS, I need a bunch of machines. AWS says, okay, fine, I can give you machines. But tell me this, if you want machines, if somebody is trying to access your website, which machine should they go and talk to? And that's a real problem, by the way. If you ever set up a website which has multiple machines, how do you tell the user which machine to go and talk to? What do you do? And how do you even make sure that, like, look, equal amount of traffic is going here, here, and here if you have 3 machines? Load balancer, right? So then hence there is a concept of one more layer of machine which is called as load balancer. So you could have multiple load balancers, but load balancer is nothing but a machine which takes which, imagine, let's say if there is a user here, takes the request, knows which machines are basically my machines. I will choose one of these machines to send the request to. Whichever machine is available, is free, is working, I will send it to that. API gateway is slightly different, Pooja. So maybe I'm not sure whether I'll be able to get to microservices today or not. But when you have multiple kinds of services, here today, right now, we're talking about only one kind of service. But imagine, let's say Flipkart. Flipkart might have a different service for payments, might have a different service for catalog. So then there is another API gateway which tells you which microservice to go to for the request that you've gotten today. For now, we'll come to API gateway later. First, let's talk about load balancer. Right? Now I have this load balancer. So I say, okay, fine. I have these machines. I'll put a load balancer here. How do I get load balancer? Maybe I should check with AWS. That I want some kind of machine that can, whose IP I can put in DNS, and this machine is responsible for making sure it is equally distributing the traffic amongst live machines, right? Folks, one by one, amongst live machines, right? So AWS says, oh wait, that is load balancer. I have something called a load balancer. You don't need to write the code for it. I will give you load balancer. I will give you load balancer. I already have something, so you can rent load balancer from me as well. Pay me some money for it, but you can rent load balancer from me, right? Now, firstly, what should I have gone and rented from requires knowledge. This part that I actually need a load balancer here is part of what is also called as system design, right? So whenever you're doing cloud computing is 2 parts. One is doing system design, knowing what components do you need. And then the second part that you need is, once you know the component, what is this component in the cloud that I want? For example, one of the load balancers thing that AWS provides is called as Elastic Load Balancer, or Elastic LB. So I can say, hey, load balancer, like, why don't I put Elastic LB here? Fine. Elastic LB has access to these machines. It sends, if let's say one of the machines is down, it will make sure that it sends a request only to the remaining 2 machines, not send it here. Correct? Now, post that, I could have more things here. Maybe as my traffic increases, I might want more machines here, right? If let's say suddenly there is a spike of traffic, if there are like, instead of 100, there are, let's say, 100,000 people accessing Delicious, you might want more machines active so that all users can access the website. But if you keep those many number of machines active all the time, then you'll have to pay a lot of money. If I was running it myself, then I would have to go and buy 100 machines and I'll have to keep them always with me. But the good thing with renting is I don't need 100 machines all the time. Maybe when the traffic spikes, then I can borrow more machines from Amazon. When the traffic goes down, I can return some of the machines back to Amazon. How do I do that though? If I try to do it manually, then it will take time, because firstly somebody will have to tell me that the traffic is going to spike or has already spiked. Then I will jump into action. Then I will get those machines. If I do it, that will take more time. Maybe by the time I'm done putting more machines, the traffic has already gone down. People have seen a website not available because the traffic is high, and everybody is very, very unhappy. So maybe what you need also is some form of auto scaling. Now, what is auto scaling? What is auto scaling, right? I want to be able to say that um, that Amazon, I don't know how many machines I want. I will tell you the range of number of machines that I want. Right? I will tell you, like, look, I want anywhere from 4 to 20 machines or 4 to 100 machines, right? But however, how you decide how many number of machines is by a specific set of rules. Now, what is an example rule, right? I could say that start with 4 machines, right? And I have to figure out, which is, as a person who owns the system, I have to figure out what happens when the traffic spikes, what thing starts to go up, what becomes the bottleneck. Hypothetically, let's say that could be the CPU. That as the traffic will increase, suddenly my machines will start to utilize a lot of CPU, and if they utilize a lot of CPU, then you'll need more machines. So then I can set a rule here saying that if my CPU utilization, let's say if CPU grows beyond 50%, then add 2 more machines. Add 2 machines again. Now see, once those 2 machines are added, then what is the new CPU? If it is still beyond 50%, then maybe add 2 more, and keep doing that till you go beyond 20, right? So you should not go beyond 20. But you use this rule, for example, to decide whether you need more machines or not. This is one example rule. But what rule to set, how to set it, is it's actually okay, all right. If you're not able to understand, let me repeat once more. So to use load balancer, you go to AWS. AWS gives you a load balancer. AWS also gives you a web interface where you can configure load balancer, right? So in this load balancer, you can write rules to say, either, I mean, your number of machines are static, that, oh wait, I always have 4 machines. Or you could say, by the way, I don't know how many number of machines. I want auto scaling. This is a feature of your load balancer. I want auto scaling. Now, in auto scaling, you'll have to specify how many machines. So you could say, I mean, minimum, always keep minimum 4 machines, maybe maximum 20 machines. And to decide the number of machines, always increase the number of machines whenever, let's say, CPU goes beyond 50%. This is one kind of rule. Or you could say, hey, increase the number of machines when RAM RAM utilization becomes more than 80%. So if I have 6 GB RAM, and my RAM utilization is more than 4.8 GB, then increase the number of machines. Because when you increase the number of machines, then the load on a single machine is going to go less, right? Because if, let's say if I have 4 machines, right? Imagine there were 400 requests. Then every machine is getting 100 requests. If I increase it, imagine if I have now 8 machines, then the moment I increase it, if the load balancer is equally splitting the traffic, then each of these machines will have 50 requests. Correct? 50 requests. And when it goes to 50, then the load on every machine reduces to half. So if you start to see that the load is going high, so then load balancer can add more machines, can add the exact same kind of machines that you have based on the rule that you have specified. This is, so Bilal, you have a very good point. If these machines are storing your data, if these machines are storing the bookmarks, then how do I even split? So right now, one of the assumptions that I'm making is that we have made one split where you have load balancer. Load balancer is talking to some machine which is running your code. Let's call them application servers or application machines. And all the bookmarks, etc., that you have, we are going to put that in a database. So we're going to put that in a database. Let's say, I mean, you have different kind of databases. You could have a relational DB, you could have a NoSQL DB. For now, just to keep things simple, we're going to say that, let's say we're going to put that in a MySQL DB, where we have split the data based on some parameter, which we'll come to that later. We'll come to it, right? So imagine this is here, right? So right now we're only talking about scaling because the CPU load on these machines could become heavy. Hence, I am setting some kind of auto scaling rule here so that these machines can either be increased or reduced depending on the current traffic. Correct? So the fact that I move to cloud gives me one more flexibility. I can get load balancer without having to build my own load balancer, and I get auto scaling for free. What do you have to set auto scaling on? That requires knowledge of the system. The fact that you require a load balancer and what kind of load balancer do you require, that also requires knowledge of the system. Hence, I said system design and cloud computing, they go hand in hand. Kriti, I'll come to that. Look, we've just started with cloud computing. You're asking me advanced questions about Geo, right? Geo is what is happening at Geo right now is advanced when it comes to cloud computing. I'll come to that too, step by step, right? If I directly jump to that, then a lot of you might not understand what is happening. You might get be lost. So I want to make sure I'm going step by step. Okay. so so the first step when I moved here was, okay, fine, I borrowed a bunch of machines, I got a load balancer, I set up auto scaling. So the first component that we just used was load balancer from the cloud. Now, load balancer as well, the good thing is when you talk to Amazon and say that, look, I want an elastic load balancer. Now, Bilal, yes, you can do that. Absolutely. So load balancer allows you to write custom rules. Custom rules. It could be any rule that you want. So one of the good things is that in elastic load balancer, Amazon says, look, and I mean, as an engineer, you should be aware that what happens when load balancer goes down. But Amazon takes guarantee that, look, I will make sure there are enough backups for the load balancer. If the load balancer were to go down, there is another load balancer in its space that will take the traffic. Or if you can set up multiple IPs, then I will have multiple load balancers acting at a time so that even if one is down, then the other takes over. That is actually elastic load balancer, that as your load increases, the the kind of load balancer that you have, the resources of the load balancer, that also again changes. That is done by Amazon itself. However, as an engineer, knowing how you would have built such a system yourself is also important. So hence system design, cloud computing, both important. Okay, moving on. So we've done load balancing. We've also done virtual machines. Here also the machines that I'm getting, by the way, these could be of different configs, right? So the bigger machine you take, the more money you pay, which means if you, in the context of Amazon or AWS, there are different kinds of machines possible. For example, let me just pull up 1 second. While it is not very important, but let me just take some references just so that you understand what the basic kind, right? Right. So for example, Amazon says there are following class of machines. There are machines that could be heavy on CPU or memory or RAM, or I mean just cheap instances, right? So they have class of C, M, R, T. C are all machines that are compute intensive. So they have very good amount of CPU. So for example, if you take, for example, I mean, there is one class of machine called C6i.large. These are expensive machines. They cost you $62 per month, one machine, but they have massive amount of CPU. Very similarly, like you have another class of machines. Let's say if you don't want very high amount of CPU, but you really want, I mean, machines meant for databases, right? So they have very high quality hard disk, very high amount of storage value. Then you take M kind of machines. These are general purpose, meant for databases. So for example, if you take M6i.large, this machine would cost you like $70 per month, meant for very high quality of hard disk. So if you can store a lot of information on your hard disk, and it is optimized for fetching information quickly or writing information quickly. So if you have a lot of that usage, then this is the kind of machine that you get. Again, this is not very important. I'm just telling you so that you understand. Look, I mean, what does, let's say, even getting machines from cloud mean? Very similarly, you have R kind of machines which are RAM intensive. A machine has hard disk where you store information. It has CPU which does all of your work, and then you have RAM, which is very fast memory, but it is temporary memory, which is something you store in main memory. It's also called as main memory. So there are machines which are RAM intensive. Now this is primarily used for all kind of caching systems. Let's say you're building a cache yourself, or you want to, let's say, set up Redis, Elasticsearch, etc. Some kind of cache. What is cache? I will also come to later. uh, then you use these kind of machines. So for example, something like a R6i.large. Sorry, 1 second. Costs about $90 per month. Or I mean, you have T machines, T3.small, T4.small, which are very cheap instances, but they have bad CPU performance. So low CPU, but cheap. The exact costing I don't remember, but like for example, AWS also gives you a free tier. So the free tier would probably have a T kind of machine. Free tier means you get some machines that you can use. Think of this as a free trial, right? So you get for 1 year free trial where you get a very low quality of machine that you can use without paying any cost. Post 1 year, you'll have to start paying some cost. What is CPU intensive machine in CMRT? This is a C part, right? C part is CPU intensive, which means you have very high quality of CPU. Imagine I want to run, for example, in data science, right, or machine learning, you might want to run jobs that do a lot of CPU work. So in that case, you want to get a machine which is very high on CPU. It might not have a great RAM, it might not have a great storage. That's fine. I don't care. But I want very good CPU because I wanted to do a lot of computations in a second. Bilal, yes, yes, absolutely, absolutely, absolutely. M is your hard disk, right? So imagine I want to run a database. I want to run a database myself on a machine. So then hard disk of very high quality. For example, hard disk um, could be a SSD hard disk. SSD hard disk is flash hard disk, which is very expensive, but it is extremely fast. So a lot of high-end Mac laptops, they have SSD hard disk. SSD hard disks are fast hard disk, right? Versus let's say a regular hard disk is slow. So having M kind of machines will give you SSD kind of hard, like fast hard disk. M stands for memory, R stands for RAM. So uh, it's slightly confusing because sometimes you use memory, main memory even for RAM. Hence, I'm using the term hard disk all the time. Which companies? So this is just a regular terminology that AWS uses, right? These could be machines manufactured by anybody. It could be a machine manufactured by Dell or probably HP. Who knows? Just a terminology that AWS uses. I'm again giving you that as an example, so that when you go and like let's say try to set up your cluster, then you're not surprised that what is this. At least then you have some reference point. Okay, all right. What we will do is there is a lot still left. We've only scratched the surface. Now we will get to the slightly more advanced stuff, which is now we will start looking at things like um, Elasticsearch, object storage, queue, um, and just one second. I had a few more things that I had listed down. Just give me one moment. CDNs, and observability. Sorry, let me put here observability. We will cover some of this in the upcoming part. But before we get there, let's take a small break. We'll break for 5 minutes. And then when we come back, we'll resume with this. Through this, I want to not be this be a session where I'm only imparting knowledge. I want to show you how even cloud is nothing but a problem solving exercise. So the way we will even introduce this is I will take you through the story of Delicious. I will pose a problem statement whenever things happen, and then you have to respond with what would you do if let's say you were in a similar situation, and then I'll tell you how should you think about it, and then what is the corresponding solution in the cloud. Okay, so that's how we will go about doing this. For now, we will take a 5 minute break. It is 9:32 right now. We will resume at 9:37. Is that okay with everybody? 9:37. Yeah. One second. I'll write it here. I will also go and get some water. Please, you do as well. And then we'll resume at 9:37.
Okay, so let's give Anshuman sir a breather for 5 minutes. Let him sip some water. In the meanwhile, guys, I also want to make a very, very important announcement. We have a free session which is going to happen this week itself, and that's also going to be taken by Anshuman sir. And I'm going to paste the link over here. So, in this class, you learn how to ace top tech interviews. Click on the link to register for the same. Also, a lot of people have been asking so many questions. I can see so many questions here on the questions tab, but due to the time constraint, it will be very difficult for us to take up all the questions, but we would love to speak to you one on one. So I'm quickly going to raise a poll over here. Just give me one moment. Yes, I hope everybody can see the poll. So this is going to be a free call where either me or my team or anybody from the team will get in touch with you. We want to understand your aspirations, your goals, understand where you are coming from, where are you currently working, your company, your role and domain, and then give you an advice or guide you to build a roadmap together. We'll help you build a roadmap together. So please click on yes so that we can get in touch with you. Once this poll ends, I also, there are so many people who have been asking about the certificate. So let me do one thing. Let me quickly share the link from where you can download the certificate, but you'll only be able to do it after the session ends. Just give me one moment. Okay. So I have pinned this link in the chat box. You'll be able to download the certificate after a couple of hours once the session ends. We'll be sharing the notes on the WhatsApp group. Some of you also have been asking for recordings. The recordings is unfortunately not available for everybody. It is only available for our enroll users. For the people who are a part of Scalar community, you'll be able to find it on your dashboard. So when you log in, you'll be able to download the. You'll be able to see the recording. I hope everybody is aligned. Okay. I'm also going to be pasting the WhatsApp group link for the people who have not joined the group yet, so that you can access the notes. I'm going to keep the link pinned in the chat box. Please save it so that you can join our WhatsApp group. I hope everybody can. Can you guys click on the link and see if you are able to join the group? Rashmi, yes, we'll be sharing the notes today. Abhishek, no, the session recording will not be provided on the WhatsApp group. It is only for our paid learners. Bilal, we can talk about all the courses and everything in detail. If you have already responded to the poll, the team will get in touch with you for the same. In the meanwhile, if you have any questions related to Scalar or anything else, the next batch, please post it in the questions tab, and I would love to talk to you guys by the end of the session. Also, guys, we have a dedicated Q&A round by the end of the session when Anshuman sir completes with his class agenda. So please be patient. Do not spam the chat. Just post all your questions in the questions tab. Upvote each other's questions which you find the most relevant, and sir will take up maximum questions that he can. Okay, I can see a lot of questions here again. Also, I'm posting one more link for you guys. If you want to get in touch with us, speak to us one on one to clear any doubts that you might have, just click on this link. Okay, I hope you all have registered for the free session which is going to happen in this week by Anshuman. Give me a thumbs up if you have already registered for the same. Let's do it within 30 seconds so that sir can join. Let me check the time. It's 9:37. So let's quickly register for that. And I think then we can continue with the class again. Okay.
Ranshi, I think people are still asking for the link, so maybe you can share the link
Sure.
in the chat once more.
I will pin it again in the chat box. Give me one moment.
Yeah. Okay, folks, we are back at 9:37 p.m. Indian Standard Time. We'll continue with where we left off, um, and we'll take it forward from there, right? So, if you remember the delicious use case once more, we had gone from this one laptop to multiple laptop because there were two problems, right? As we were scaling, one is we knew that in some days we will run out of hard disk space. Okay, I'll describe once more. So the delicious use case was, delicious is an app which stores user to the list of bookmarks, right? Now user to list of bookmarks, right? As the app became popular, there were two problems. One was the number of bookmarks being added to the DB was increasing the amount of hard disk required, and hence we saw that we will run out of space at some point of time. So what do? Then we need more machines if we do horizontal scaling. If we need more machines, then how do we manage so many machines? That was one problem. And hence we started looking at cloud, right? So we, and there I told you that, look, there is, we can probably get a load balancer, which is elastic load balancer. Then we have a bunch of these machines which get added or removed, and these machines are not storing the list of bookmarks. They're only running the code that I have, so that they know what to do with the new request that comes here. However, we still haven't solved the problem that we started with. The problem was, imagine if I'm using currently a MySQL DB, right? If I'm using a MySQL DB, this is a, you have databases, right? So in computer science, you have databases where you can store information. One kind of databases is relational databases, which is the most popular form of databases that you use. Um, and in cloud, again, if you have to, let's say, use or if you have to set up relational databases, you can use something called as RDS. In RDS, you can configure a MySQL or Postgres, any kind of relational database. This relational database is exactly like an Excel sheet. In Excel sheet, just like every tab has rows and columns, in a database, in a relational DB, you have tables. A table is exactly rows and columns. You could have a large collection of these rows and columns. So you have multiple tables, and you can fetch information from these tables. Very large tables, you can fetch information quickly from these tables if you have the right index build. Now, I'm not going to go into depth of what a relational DB is. However, I am going to pose a problem statement to you, which is, the problem statement that we had started with was all of the information. Uh, ELB is elastic load balancer. Sorry. Right. The problem statement we had started with is that the number of bookmarks are increasing at such a fast pace that I am going to run out of space. I mean, at the end of the day, even this relational DB is a machine, right? It's a machine. Even the machine is going to run at some point of time. This machine is going to have some limited amount of hard disk. It's going to run out of that hard disk space. If that happens, then what do I do? If Pooja, Manan, I'll come to your question. Can we focus on this part once? Um, what can we do here if this machine is going to run out of space? How do you fix it? Okay, one is you scale it vertically, absolutely. So there's, yes, you can make it a bigger machine, you can get better hardware, but at some point of time, that even that hardware is going to run out of space. Either it's going to run out of space, or it is going to become so big that fetching information becomes very, very slow. So now you're saying that we let's scale horizontally. Horizontally means let's get more machines, right? Now getting more machines only makes sense if I am able to, if let's say if I had 100 GB information, right? If I'm able to break this information into three parts, where some part resides here, some part resides here, and some part resides here. If every information is present everywhere, then it doesn't make sense. I'll have to split this information across these machines. This splitting the information across machine is called as sharding. It's a fancy term which just says, if you have, imagine, 10 entries, how do you split it so that 3 entries go to machine number 1, 3 entries go to machine number 2, and 3 entries go to machine number 3? Question is, how do you shard, and what do you do in the cloud to be able to shard? Okay, okay, I understand. Some of you might not know. That's fine. That's fine. That's fine. That's fine. Right. So the way to shard is, imagine you have a lot of these, right? You have user. User has a bunch of bookmarks. You might have a user 2. User 2 has a bunch of bookmarks. You might have a user 3. User 3 has a bunch of bookmarks. user 4, and user 4 has a bunch of bookmarks. The first thing you have to decide is what is the, how do I split this entire information, right? And there, if you see, the bookmarks of a user number 1 is independent, or is not dependent at all on the bookmarks of user number 3 or user number 4 or user number 2. So I mean, in theory, if let's say user 1 was present here, user 1's bookmark was present here, maybe user 3 bookmarks were present here, it will not cause any problem, because when user 3 comes and asks that give me my bookmark, I will go and talk to this machine. When user 1 comes and asks that give me my bookmarks, I will go to this machine. I'll not have to talk to multiple machines. I can talk to only one machine and I will get all of my bookmarks. When you say that add a bookmark, then also I have to go to only one machine, right? Okay, what does bookmark represent here? I'm a bit confused here. So you typically bookmark a website. When you bookmark a website, in that website's URL, the website's address, the entire link, you save that as a bookmark, right? So I could have bookmarked 100 websites. So all of those 100 links will be there in my bookmarks list. That is bookmarking. On your browser, as I said, there's a star icon. If you click on it, it bookmarks. So one of the things I can do is I can shard based on user ID. I can say that, look, a user needs to be part of only one machine and one machine only. Two users need, two users could be on two different machines, but a user cannot have their bookmark half here, half there. And that is called choosing the sharding key. In this case, your sharding key is user ID. I'm sorry, I'm just covering this concept faster. If I had a proper system design class, then I would have explained it maybe in more detail. But you choose a sharding key. In this case, the sharding key is user ID. That means if you had like all the users, right? Let's say you had 10 million users, you allocate some users to this machine, you allocate some users to this machine, and you allocate some users to this machine. Um, I'm coming to that. I'm coming to that. Like, how is it relevant for cloud, right? You allocate some of this here, and then when a request comes to this machine, let's say it wants to get the bookmarks for a user, I look up which machine does this user belong to, and I go to that machine to fetch the bookmarks. Now, how do I store this mapping, etc., etc.? There are techniques to do that, like consistent hashing, which we will not discuss in today's class. I might be able to send you a video on that, some other masterclass that we might have done, where we explain consistent hashing in a lot of detail. However, that brings us to how do I make sure that that happens in a cloud? And that's where the choice of what kind of database do I need, choice of database, and how to set up sharding in it is important, right? Um, so you have broadly relational databases and you have NoSQL databases. In general, again, if I had time, I would have gone through architecture of all NoSQL databases. But in most NoSQL databases, sharding is supported out of the box. What you have here is nothing but a key value kind of storage system, right? You have key as the user ID and the value is the bookmarks. If you can have a lot of bookmarks, then maybe you don't need just a key value. You probably need a key to some form of either document or a column family, which are also, NoSQL terminologies. For now, because a lot of audience here is beginner, so ignore this part. Imagine I have key and I have a corresponding value, which means I have user ID as the key and a corresponding bookmarks list as a value. There are a bunch of um, NoSQL databases that support key value and support sharding, where you can specify the sharding key as a configuration. Um, okay, Kriti, is everybody able to see my screen? I mean, what I'm writing on the screen, is that visible to everybody? Okay, Kriti, I would request if you can refresh, because typically it happens when your network is slow. Okay, so um, so maybe the choice of database is the first step. What kind of database should I choose? Which, let's say, can support key value or key to something, and can support sharding as well out of the box. So yes, I mean, for example, in AWS, you have DynamoDB, you have Amazon. If you needed, if you needed document DB, so AWS has uh, a database like MongoDB, which is Amazon's own document DB. Why are you referring to AWS always? I mean, so look, I could refer to Azure, I could refer to Google Cloud. For now, I'm referring to one of the cloud systems, just so that you don't get confused. And I'm referring to AWS because if you look at the distribution of companies using cloud, as of today, AWS is the most popular. Um, Hence, I'm referring more to AWS. However, I'm sharing a link with you. This has the corresponding DBs in every cloud. So what you have to understand is, the reason why I'm giving you this example is not to say that you have to know what uh, what is the name of, let's say, this kind of DB in AWS. That's less important. What is more important is when you see that, oh wait, I'll not be able to store everything in a single machine, or my performance will degrade in, let's say, a relational DB. Then what kind of database should I explore? What is the best database? That skill is more important. And that particular database, right? Once I know that, okay, wait, this is a DynamoDB, or let's say I need a MongoDB, what is the equivalent of a document DB, or let's say a Cassandra kind of a DB in AWS, Azure, or GCP? That's super easy. I've just shared a link with you. You'll get that in one click, right? Could be Aurora DB as well. Yes. However, look, I'll stress once more. There are two kind of companies that hire. You'll have service companies that hire, you'll have product companies that hire. Product companies rarely focus on the knowledge of a particular terminology in a particular cloud. They focus more on, given this scenario, what kind of database do you think will work best and why? Tell me the pros and cons. I'm not writing anything here, Deepak. So right now it is right. And then finding that, oh wait, what is the equivalent of this DB in AWS or Azure or Google Cloud? That is super simple. So my request to all of you is, knowing this is great to have, but do not assess your skill by the fact that whether you know what is the equivalent of, let's say, document DB in AWS or Azure or GCP. Right? That's super simple. That's knowledge. First, understand the fundamentals. What kind of document for what kind of use case, right? That's the more important skill. Hence, I'm giving you these scenarios instead of saying that now put DynamoDB here, now put this there, now put that there. I'm not telling you that. I'm giving you a scenario. We're looking at the solution, and then we're figuring out what possibility, let's say, in AWS. Very similar. I mean, just using the website, you will find the same possibility in Azure or in Google Cloud. Is that okay with everybody? This is not to say that, look, AWS is superior to Google Cloud. No, not at all. This is not to say that AWS or like Azure is superior to AWS. No, not at all. What is most superior skill to have is understanding what kind of system do I need. Finding the equivalent of that in the cloud is easy. So first, understand systems. That's the most important skill to have. Do you agree with that? Okay, all right, cool. So fine, maybe we did shard the DB, and imagine hypothetically we ended up choosing DynamoDB. Again, someday if we had more time, we'll talk about sharding. We'll talk about NoSQL DBs. Why do they exist, etc., etc. That is part of system design. But let's say we end up at a state where we have now a load balancer. We have these machines, and we have, hypothetically, let's say DynamoDB. Hypothetical, right? Um, okay, differentiate AWS and cloud computing and how are they related? AWS is a kind of a cloud provider. AWS is Amazon Web Services. It is one of the cloud providers. You remember I said there are these large companies you can go and rent machines from. AWS or Amazon Web Services is one of those companies you can go and rent machines from, right? So it's a cloud service provider. Okay, moving on. Let's look at more use cases, right? And then let's figure out what kind of system do you need, and hence what kind of thing would you need to add. Oh, okay. uh, Now imagine Delicious says I want to add more features in it, right? Neil, I have to also deal with all kinds of audience, right? So hence I'm very sorry that for some of you I'm not going very fast. But look, at the same time there are some people who might not even understand anything, so I have to take everybody along. So I'm very sorry if some of you feel the session is going slow. Quick check: how many of you feeling that the session is slow? How many of you feeling that the session is fast? Yes if you feel the session is slow, no if you feel the session is fast. Okay, you see, like there's 50% split there, right? Like what do I do? Anyway, I'll do my best. So let's go to the second use case. Now imagine that Delicious decides that let's add more features. I want to get more traction. So they decide that now let's have users create accounts, and maybe users can follow each other, right? So imagine I start following Karthik, and if I follow Karthik, then I can see what kind of bookmarks is Karthik doing, so that I can maybe go and read some of those articles, and maybe I can also go and bookmark those, right? Let's say I want to build that feature. Now, if I want to build that feature, one of the things that I might need is, apart from user profiles, I might also need to be able to store their images. And let's say there is a profile pic that I might need to store, right? If I want to store profile picture, do you think I should store the profile picture in a DynamoDB or let's say a MySQL kind of DB? Relational DB? Like, does it make sense to store a picture there? The entire picture, which is like a large file, right? It doesn't, correct? It doesn't, right? So then you have to think of what kind of place should I store an image, and how do I make sure? Let's first start with, like, where should I store the image, right? Obviously, DynamoDB doesn't make sense. MySQL doesn't make sense because it is an entire blob of a file. I will never ask the question that show me an image which has, I mean, choose the image which has something inside the image. Maybe these kind of bytes inside the image. My question is always going to be, hey, give me the image for Nikhil. Give me the image for Anil. That's going to be my query, like, right? So give me the image corresponding to Anil. That's going to be my query. So maybe in DynamoDB, I only store user ID to the link of profile pic. But the actual profile pic, I should be storing somewhere else, which is like a file storage system. So if you have file storage, then yes, very right, Ashish. Um, different clouds, different cloud providers have different systems like that. For example, AWS has S3, Azure has Azure Blob Storage. So you could look at something like an S3 or Azure Blob Storage to store files. And when you store a file here, then you get back a link to the S3 system. Right? These are typically called as object storage systems or file storage system or blob storage systems, right? That's the category. That's the category. In this category, obviously, every cloud has their own kind of systems. But you want to store a large file like an image or a video. It doesn't make sense to store an image or a video in, let's say, a MySQL DB, right? It doesn't make sense to store it in a row column kind of a DB. It doesn't make sense to store it in a Dynamo DB either. So hence, because they're not built for storing large files, they're built for storing some key to some value or some rows and columns. So hence there's a different kind of a database which is called as object storage database. And there you have, I mean, in AWS you have S3, in Azure you have Azure Blob Storage where you can store files and they give you link back to the file. Here one more case arises, which I'll again point to you. So fine, I have stored it in S3. Imagine I went and folks, just hold on. Let me ask you a question. Imagine these machines that you had rented from Amazon. This is not blow, this is blob is a large sequence of zeros and ones. Okay, imagine that all of these machines that you rented from Amazon, that was present in, let's say, Singapore, right? So it is going to be, I mean, all of these machines are going to be physically present somewhere, right? So let's say they were physically present in in Singapore. So imagine all of this is in Singapore. Imagine you are today sitting in United States. You're sitting in US. Ramesh, hold on. Hold on. You're sitting in US and you want to fetch information from Delicious, right? Which means, let's say you want to go to somebody's profile and you want to fetch their profile. Now, their profile is going to have their name. It might have some details about them, but it is also going to have the picture. Let's say this profile pic is 5 MB or 50 MB if it is very, very high quality, right? So let's say 50 MB pic. If I'm sitting in the US, then fetching this 50 MB file by going to Singapore, going through a machine, then downloading it from S3, and then porting it back is going to take a lot of time, right? If you're downloading 50 MB from like across the continent, it's going to take a lot of time. So what can you possibly do? As Delicious, as the owner of Delicious, you would obviously want that this happens quickly. So what do? A lot of you are saying CDN, cloud distribution network. Yes, absolutely. Caching. You would want to cache, you would want to use a CDN. Let me explain what CDN is, right? And then we will also discuss what kind of CDNs in different clouds are present. What kind of options do you have? Because this is a problem that every website is going to face. If you're Facebook, then also you face the same problem. You have images, you have videos. Users are all around the world, but your data center is in some part of the world, right? It is fixed. Either it is in US, or it is in Europe, or it is in Singapore or somewhere, but it is fixed at one part of the world. But your users are all around the world. Some users are close to you, some users are far away from you. And that is bad for a website, because users that are close to you, they get a very good experience. But users that are far from you, they get a very bad experience, because every time they have to download these images or video, it just takes a lot of time. It has very high latency, right? So then what do? So there are these companies that came into being. For example, one of those companies was Akamai, but there are a lot of these companies like CloudFront, Cloudflare, Fast. But I'm going to take one example there. So there are companies like Akamai that came into being. They said, look, we are going to do another kind of cloud, right? Which is, we are going to deploy machines all over the world. We will have machines in India as well. We'll have machines in Bangladesh as well. We'll have machines in Singapore, we'll have machines in US, East Coast, West Coast, every coast. We'll have machines in South America. We'll have machines all over the world. Now, why is that important for you? You pay me some money. You give me an image. If I'm Akamai, you give me an image. And what I'm going to do is, I'm going to keep a copy of that image in every sector of the world. So when a user comes and wants that image, they don't need not come to you. They can come to me, and I can redirect them to the closest machine where they can download the image from. Which is to say, imagine this is the world. Here is Singapore. Here is US, hypothetically. Again, I'm very bad at drawing maps, so I'm not going to draw the maps. um, Imagine this is where your data center was, right? You uploaded somebody's image. When the image was uploaded, you stored it in S3. At the same time, what you also did was you uploaded this image to Akamai. You told Akamai, hey, save this image. Akamai said, okay, fine. I have saved your image. By the way, here is the URL to the image. Let's just call it CDN URL. CDN link of this image. So wherever any user is trying to access this image, please give them this URL. They should try to access it using this link. Now, when a user fetches the page, let's say user is here, user fetches the page gets a bunch of HTML with the link to an image, saying that here is a image. The link is the CDN link. Because it's a CDN link. CDN is content delivery network, right? So it's a link of, it's an Akamai link. Akamai is a company that does this. So it's a Akamai link, which means I go to one of the Akamai machines to say, hey, look, I have just gotten a request to download this image. What should I do? And Akamai would say, fine, you don't need to go to Singapore. I have machines all over the world. You can download it from here. I can give you the download. Right? So hence we get to getting these images or media files or videos really, really quickly. This is called as CDN, content delivery network. So you have machines all over the world. I mean, you don't have machines all over the world, but you rent resources from larger companies who have machines all over the world. Obviously, you yourself cannot buy machines all over the world, but you can rent for a small cost. And Akamai says, I will charge you some money for resources that you ask me to save, and I'll charge you some money whenever users download this image. That cost is not a lot. It is not going to make or break, but it saves you a lot of cost, right? Because you can now use the service. So this is a different kind of a cloud. CDN is a different kind of a cloud. You're borrowing some resources from a provider who has machines all over the world, so that when it comes to downloading very heavy files, instead of having to download it from you, from your data center, they can download it from the nearest machine of the CDN provider. Again, you would know you have to use CDN if you started with the problem statement of, my users are finding it very, very slow to download the image. What are the solutions that I could possibly have? Oh, wait, there is something like a CDN. Why don't I set up a CDN? Now, if you're using AWS, AWS has CloudFront. I mean, irrespective of database, I mean, there are other called, like, let's say Cloudflare. Akamai is a CDN. Fast.com is a CDN. So you have a bunch of these CDNs. You can use any one that you believe fits your budget. Different websites might use different CDN networks. So if, let's say, I use Akamai, then Akamai will have some copy of my data stored in their local data centers. Scalar uses CloudFront. So we use CloudFront. So if you see a lot of our images, videos, when you go and click on them and try to get the URL, you'll find a URL which has something like something.cloudfront.something, because you're getting that image from CloudFront, not getting it from Scalar, right? That gives you data redundancy, but also gives you data quickly. Salesforce, I don't know whether Salesforce would qualify as a CDN. Uh, Salesforce is meant for a very different thing. Yeah, my display profile will be on. That is on S3. Okay. We haven't cached it, right? So that's a part that we missed. Then ideally it should be on CDN. Right. Okay. All right. So we've now also learned about. One second. Where was I? I was maintaining a list. Oh, we can maintain the list once more, right? So we've discussed now load balancer, databases. Now discussed object storage. We've also discussed CDN. Why do we need CDN, right? I'll again pose a few more questions, so that this is just introducing you to different components in a large system, right? And these components obviously translate to some version in the cloud. So we've now solved the problem of downloading image. Um, just a quick check, because I still am getting questions. Is the part about CDN clear to everybody? Like, why do you have CDN? Why do you need CDN? Broadly clear? Some of you are saying no, but most of you are saying yes. I mean, in the interest of time, I'll just move forward. Just the way to think of it is CDN is sort of like cloud. However, it is all around the world. You borrow some resources, you rent some resources for them, so that they store a version of your file everywhere. They store one version in US, they store one version in India, they store one version in, let's say, Africa, they store one version in South America, so that your users there can get those images quickly. That's it. Amazon already has a CDN, which is called as CloudFront, but it costs you more money. Okay. GCP also has it. Yes, GCP also has it. Azure also has it. If you go to the website that I shared with you, compareclouds.in, there you'll be able to find what kind of CDN does every cloud provider have. So Amazon has CloudFront, Azure has Azure Front Door and Azure CDN. Very similarly, which one is GCP? Yeah, GCP has Cloud CDN, and then like Alibaba has their own CDN, Huawei has other CDN, etc. So every cloud provider has their own CDNs. Okay, so moving on. Let's look at another use case. Imagine now that all of the bookmarks that you've done, okay, is it for only for images? It is all for large files. Now large files could be your image, could be a video, could be, let's say, a large JavaScript file, right? That could also be a large file that you want to store on CDN. Any large file that you want to store on CDN, which your users might want to download, that is there on the CDN. CDN doesn't care whether it's an image or a video or anything, right? It just knows that you have given me a file. Whenever you ask me for it, I'll give you. Simple. Okay, let's look for one more use case, right? Imagine that now Delicious says that we want to add one more feature. We want to allow the users to search for content in their bookmark. Let's imagine I have bookmarked these 10,000 or 100,000 websites, which are blogs, and then the blogs have some text in it. You want to search through them. You want to maybe search for bookmarks which are about AI, or maybe you want to search for bookmarks that are talking about vaccination. If you have to do that, one is you can search through the title of the bookmarks, but the title might not contain the word vaccination, but maybe the article contains the word vaccination, and you want to look at those bookmarks. Now, where do you store information the content of the website so that you can search quickly for text in it. Then you could say, maybe why don't I store it in my MySQL DB, right? If I was using MySQL DB earlier, I could have stored it there. But the problem is searching for words in a large section of text is very, very inefficient in, let's say, a MySQL kind of a DB. It is called as a full text search. Full text search is very, very inefficient in a MySQL kind of DB. Very similarly, even in a Dynamo DB, any kind of NoSQL DB, if you have a very large form of text and you want to search for some text inside it, some substring of it, it's very, very inefficient query. So, as Rajan is also pointing out, you have one database which is built specifically for full text search, which is Elasticsearch. There in Elasticsearch, what Elasticsearch does is it creates a reverse index. So if you give it a very large paragraph or a large text, it creates a reverse index on every word, inverted index on every word, right? This word was present in which document at what position. So now, hence, if you say that, tell me where the word vaccination was, it can just quickly look up that map to say, oh, vaccination was present in document 1, 5, 6, and 10, right? And then I can give you back those documents. So Elasticsearch uses that. Now, look, when I give you that use case, the first thing you should know is that a database that can fulfill this requirement is Elasticsearch. Then you go to the second step, that, okay, I want Elasticsearch. What is the option of using Elasticsearch in AWS? Or what are the options present for something like an Elasticsearch in, let's say, GCP, or let's say Azure, right? But the first starting point is, I want a system like Elasticsearch. So if you know that you want Elasticsearch, then you go to what are the systems that implement Elasticsearch in this cloud, and then you select that, and then you set that up. Okay, some people are asking, what is Elasticsearch? Again, I'll give you a very brief overview, but keep in mind that I can take one full class on Elasticsearch, right? So this is a very, very brief overview. I would have loved to spend more time, but we have limited time, right? So hence, I'll try to speed it up. So before Elasticsearch, I want to talk about a system called as Lucene, Apache Lucene. So Apache Lucene is an open source software that was built to do exactly this, which is, if I give you a large amount of text, basically I give you a lot of documents, then can you index word by word, so that when I tell you, hey, show me documents that contain the word good vaccination, then you can return the matching documents which have exactly good and vaccination words occurring right after each other. The way it works is simple. Imagine if I have saying that I have a bad throat. I don't think I had a good vaccination. Let's say if this was the entire document, right? So what it does is it takes every word, it breaks it down word by word. Entire document, it breaks it down word by word. By the way, I'm not promoting any form of anti-vaccination thing. This please do not treat this text on to mean anything else. This is just a random text. I don't want to end up on social media with okay. So what it does is it breaks it down word by word, and then it says, oh wait, I have following words. I have a word have, I have a word I have the word bad, throat, I is coming again, I have another word don't, think, I had is also there, etc., etc. A good is there, and then there is a good, and there is a vaccination, right? Then it says, look, all of these words as a second process, they are one, I mean, all of this a and the, etc., all of those are removed from this list, right? Because they, I mean, at least Elasticsearch or Lucene consider that they are not important for the search. People usually don't care about that, right? So you remove a, yeah, I think that's mostly it. Then you reduce every word to its root word, right? For example, ran and run, they have the same root word. So if somebody is searching for run, then even ran should match. So all words which are English words, they are reduced to their root word. For example, had is also reduced to have. So it's removed from here. Very similarly, yeah, I think that's it. Which is, yeah, the lemmatized step, right? You remove all stop words, so all bad words are also removed, stop words are removed. Then you reduce words to their root words, and then you say, okay, fine, now I have the words. Now I will store, I'll treat this as a hash map. So I occurred on, in this, let's call this document number 1. So I occurred in document number 1 at position 1, and it also occurred in document number 1 at position 1, 2, 3, 4, 5, 6. Very similarly, have occurred in document number 1 at position 2, and it also occurred at 3, 4, 5, 6, 7, 8, 9, 10 here. Actually, it occurred, I had 3 occurrences, doc 1, 9 as well. This is doc 1, 10, and so forth. You do it for every word, right? Now when you ask me that, tell me where all the word have has occurred, I can just look at this hash map. It shows me, oh, it has occurred in document 1 at position 2 and document 1 at position 10. So I get that very, very quickly. Search engines are a little more advanced than this because they have page ranking and a bunch of other things that are also playing a part in figuring out which are the matching documents. But I mean, this is the rough algorithm of how Lucene works. Elasticsearch is nothing but it uses Lucene, but it is built in a distributed setup, which is it has multiple machines running Lucene. Yeah, similar, not same. Absolutely. Yes, yes, yes. Okay. The term good vaccination, there are more than one, then how can we resolve this? So then you'll get multiple documents as matching, right? You could say that, oh, wait, it has occurred in, I mean, good vaccination has occurred in document 1 as well. It has occurred in document 10 as well. So you will show both in the matching of, here is where I'm getting the match, correct? So that is your Elasticsearch. Now, once you know you want an Elasticsearch kind of a system, then you can look up the same website that I showed you to see what is the equivalent of Elasticsearch in AWS. So for example, AWS has Amazon Elasticsearch Service, or Azure has Azure Search. AWS also has Amazon Cloud Search that you can use for this exact kind of indexing if you want to do. OpenSearch, okay, yeah, OpenSearch also does it, right? Is it clear to you that when it is about indexing large documents which have a lot of text, then you need a different kind of database to index it? Putting it in, let's say, MySQL or putting it in DynamoDB might not be the best kind of thing to do if you have to search for certain words. You can't even store it as a file in S3 because how do you search then for certain words? Imagine, for example, one example could be, imagine in Scalar, we want to index all your resumes so that we can search for people who have written React in their resume or people who have written front-end developer in their resume. If we want to search for those, then we can't store those resumes in just S3 and be done with it. We'll have to also read whatever is there in your resume and we'll have to put it on Elasticsearch so that we can do the search quickly and know that whose resume is matching. which documents, which resumes are matching. Then we go and fetch those documents and then show it to you. So that gets us to Elasticsearch, which is another kind of storage. If you see databases, SQL, NoSQL, object storage, Elasticsearch, these are different kind of storage. Let me take another example, which will introduce one more concept to you. Hypothetically, let's assume that Delicious also wanted to build some kind of a notification system. Let's say you follow a user, right? And you want to send out a notification. Whenever a user bookmarks a website, you want to send out a notification to all their friends. All the followers should be notified that this person has bookmarked a new website. You should also go and check it out. Let's say hypothetically you have to build that, right? Now, what happens? Let's say a request comes to my load balancer. From there, it goes to one of the machines, and the request is, hey, user number one has added this site number one as a bookmark. I say, okay, fine. I will store that in the DB, corresponding DB. I will add this site one in the bookmarks. Super simple. Then the next part is, I also have to notify the friends or the followers. Firstly, I could have a large number of followers, right? What if I have 10,000 followers? If this machine was to run a loop, I mean, first is it has to go and maybe fetch my followers. So I have to first get the number of all followers. And two, then I have to run a large loop, sending a notification to all of these 10,000 folks. What if this machine dies in between? What if the process dies in between? Something happens. A lot of people will not be notified then, right? That is bad. Do you agree? If I run a loop of 10,000, notifying 10,000 people, if let's say the process dies, then maybe there are 9,000 people who are not notified. There is no way to retry either. How do I retry sending those notifications? Because the bookmark has been added. I don't want to add it again. However, notification I want to send again. It is possible the notification also takes time, right? Because imagine I send a notification to Imran, and Imran is currently on a mobile which is not connected. So I hence have to send a push notification. Let's say via the Apple API, Apple notification system API. And this takes a lot of time to respond. I mean, when I call the Apple notification system API, it probably takes 10 seconds to respond. Now I can't wait for that 10 seconds, right? This particular user who added bookmark is waiting that when will my request come back and tell me that I'm successful. So hence, for use cases like this, you use what is called as a message queue, asynchronous message queue or persistent message queue. Sahara, I'll come to that. Let me finish this part. I'll maybe try to repeat the reverse indexing part as well. So for these kind of systems, you want a queue, a persistent queue, a queue that guarantees that I'll not lose your message. And there you could say that, look, here is a queue. I'm enqueuing a job here, which is notify all followers of user one. Typically a queue, like Kafka, exactly like Kafka. Typically a queue has one machine that is publishing a job, which is called as a publisher. And then you have, RabbitMQ is another queue, SQS is another queue, all different kinds of queues, right? Anything fits here, but we'll come to that. So you have a publisher that is publishing job here. You might have a consumer, maybe another machine that consumes jobs from here. They are called as consumer. Right? So a consumer might consume this job, figure out who the 10,000 people are, and maybe Now, instead of sending notification directly, because sending notification will take a lot of time, again, failure might happen. So maybe what I do is I enqueue. I become another publisher and I enqueue these 10,000 jobs, separate 10,000 tasks on again a messaging queue. There might be another consumer that picks up one job, one notification, and tries to deliver that notification. Right? So that could be another use case because you want to execute this asynchronously. This need not be done as part of the same request. The user need not wait for the request to succeed. Right? When you add a bookmark, you need not wait for all of this to happen before returning success. You can be shown success that yes, your bookmark has been added the moment your bookmark is added to your DB. The moment it is added here, I can show success. But I don't want to lose notifications. So I write it to your DB. I enqueue a job on the queue. This queue is persistent, meaning it stores the information in a way where it guarantees I will never lose this information. You have stored it with me. It is going to be present on multiple machines. Even if I die, this machine dies, there is some other machine which will have this information. You'll never lose this information. So hence you can now go back and tell the user, look, successful. Sorry, 1 second. Look, successful. Now this sending notification thing can happen in the background. It might take 1 hour to complete, but that's okay. That's okay. It will take its time to complete. That's okay. It's happening asynchronously. Now, what kind of a queue to choose? Because there are different kind of queues that are out there. They all have their pros and cons. For example, a bunch of people took some names here. You have Kafka, you have RabbitMQ, you have SQS, and a few others. Which is the best queue for you? Depends on your use case. What kind of throughput are you expecting? Yeah, some people use Firebase as a queue. Some people use Redis as a queue as well. So Redis is also used as a queue in some cases. Firebase is also used as a right. You have a bunch of these kind of queues. Which kind of a queue is best for you, your use case, based on the kind of throughput that you're expecting? What are the kind of reliability guarantees that you need? What is the kind of durability guarantees that you need, etc., etc.? Depends on the use case that you have. All of these will have different pricing based on what you need, what kind of latency, what kind of reliability. How do you best utilize that queue? For all of that, you again need the system knowledge. For example, let's say we pick Kafka. So Kafka says, look, one of the things that I am able to do, which other queues can't do, is I can give you ways of generating very high throughput, which means you can put a lot of jobs on me, and I can generate like a throughput of like a million or tens of millions requests per second. It is fault tolerant as well. And how does Kafka do that? Kafka says, look, you can create topics, and within topics, you can create partitions, which allows me to have a lot of machines which can work in parallel. Now, again, if we had more time, I could have discussed the architecture of Kafka and how is all of that possible. But again, the reason why I'm taking this example again is to show you that cloud computing is not just about knowing that, oh, there is something like a messaging queue and there is something like Kafka. I'll just put Kafka. It is about understanding the detail of, for my given use case, what is the pros of cons of, let's say, using a database versus using a messaging queue versus, let's say, using within messaging queue a Kafka versus a RabbitMQ. What is the best trade-off for me, and then using that trade-off. That's the skill that you need, not the knowledge that, oh wait, AWS has something called as a SQS. That's not, that's fine, that's good to know, but the real system knowledge is what helps you in doing cloud computing. These were some of the examples that I wanted to show to you, to show you that your overall system. Sure, Docker is remaining. Yes, Docker I'll come to. But in an overall system, right, the takeaway that I want you to have is the starting point of cloud isn't, I mean, one common mistake everybody makes is they start going after terminologies, they start learning definitions, they start learning, oh wait, here are the number of systems, let me memorize all the components of AWS and then I will be great. Or let me memorize all the components of GCP or all the components of Azure. That is not the skill that you need. The skill that you need is, if I am designing a system, yes, Dinesh, yes, okay. There is observability that is still remaining, and there is Docker that is still remaining. I'll talk about these two as well. Just let me summarize, please, because this is important. The thing that you have to understand is when you start building systems from scratch, then what are the trade-offs that you should be thinking of? An Instagram's architecture would look very different from, let's say, a Facebook's architecture versus, let's say, Gmail's architecture versus, let's say, a, um, a Google Maps architecture, right? What are the pros and cons? Why are certain components used here? That's the primary skill that you should have. Once you know the components, then finding the corresponding component in an AWS or an Azure or a Google Cloud is super simple. And as you start using these components, you start to learn about certain other nuances, which is where your experience comes in. All of this, by the way, because there was a question that Joe had asked, do we learn all of this at Scalar? Yes, absolutely. All of this, actually, in Scalar, when we start system design, we start with exactly the same example, the delicious example. We start with a delicious example. It's just that what I've covered here, probably in 2.5 hours, there it takes uh, 18 classes, which is roughly 54 hours of teaching to cover every aspect in detail, where we get into the architecture of each of these. For example, in Kafka as well, we discuss the architecture, we discuss all pros and cons, we discuss why do you have consumer groups, why do you have topics, why do you have partitions. If given case 1, 2, and 3, what should your configuration be? Why so? Right? Very similarly, when we talk about Elasticsearch, then we get into the architecture of Elasticsearch. Even Elasticsearch internally has sharding. So when you have a lot of documents, then how does Elasticsearch handle a lot of documents? What should your sharding strategy be in Elasticsearch, right? Those things I can't cover today. Very similarly, when you talk about caching, right? So in caching, you would have global caching. So you could use Redis. You could have local caching. Caching happens at all levels. So CDN is also one form of caching. Caching also happens on browser. Caching also happens inside your database. So how does caching happen at every layer? What's the right kind of caching parameters to set, depending on different kind of architecture that you want to build, depending on whether consistency is more important or availability is more important? We discuss all of that. I can't do that in a single class here because of limitation of time, but those are the most important aspects. Translating that to cloud is easier once you understand the fundamentals extremely well. I mean, then your ground is laid. Then growing small trees on top of that is easy. But you want a fertile soil, you want a very solid ground that you can grow these trees on. That's the important bit. Let's also talk about observability and Docker, because there's been, those two things have also been brought up multiple times now. Same example of delicious. Look, one of the things is that while I have taken on rent um, these machines from AWS, one of the things I do want is that if my machines go down, if my users are not able um, to use the service, or let's say, for example, let's say a user one makes a bookmark. User one bookmarks, let's say, a website one. And in response, what should happen is, here are user 3, user 5, and user 7. They should have been notified. But imagine user 5 was not notified. Then one, knowing that there were some users who were not notified, and two, knowing where exactly the failure happened, building systems for that, that is called observability. Like, but let me explain what I mean by that. If you see here, sending notification goes through multiple steps. I mean, if you look at the steps, let me use a different ink. Your request comes to load balancer. From there, it goes to this machine. From there, it goes to the DB. From where, after which it comes back here, then it goes to the queue. From the queue, it might go to this machine. From this machine, there are a bunch of jobs again enqueued here. And then each of these jobs are going to this machine. And from here, the notification is being sent. So if you see, it takes 1, 2, 3, 4, 5, 6, 7, 8, and 9. 9 steps to finally send a notification to a person. If one person did not get the notification, then where did the failure happen? What part was missing? It becomes incredibly hard to debug in this kind of a case, right? If I ask you that you have these many components, how do you know where the failure happened? What would you do? How would you set that up, right? That's the primary question. How do I set this up? So to solve for these kind of cases, there are certain things that have, I mean, because this is a problem that this is not being faced for the first time, right? So logging, but Prakash, logging wise as well, how do you check where the failure happened? Because if otherwise you'll have to go to every single component, look at everybody's log, and then figure out where the failure happened. In fact, you don't even know like which particular log should I be looking at. So Splunk, yes, Splunk is one. So there is, hence, I mean, there is something called as observability, which is how do you trace requests across multiple machines? How do you look inside every service? How do you look at the overall of every service as well? So there are basically two terminologies that are being used. One is monitoring, which is your regular metrics, plus observability, which is how do I trace the request all across. Now, few things that help there is what if. Okay, one of the things, for example, you could do is that if a request comes, maybe I put a unique ID with every request. Let's call that trace ID. So wherever it goes, whenever I log something, I log it with this trace ID, right? And maybe I log it into a central system. Imagine that there is an Elasticsearch service here. So all logs are going to my Elasticsearch system. All logs from here as well, logs from here as well, logs from here as well, logs from this queue as well, logs from this system as well, and this system as well. I'm just taking an example, by the way. It doesn't mean that I love Elasticsearch. You could use Datadog, you could use Honeycomb, you could use Splunk, you could use um, anything, right? This tracing log that is happening to going to Elasticsearch as well, it happens as a async process. What does an async process mean? Async process mean that if this is my laptop or machine, right? As you are doing stuff which is important, the logs that you're generating, maybe you pull it in a file here, and time to time, when let's say there are no active requests, or when there are less active requests, then you flush these files to the central Elasticsearch. They need not go to the Elasticsearch immediately. You maybe batch it and send it without blocking a request. It's happening as a parallel, process, independent of whatever is happening on the main machine. Now, once I have that on Elasticsearch, then the thing is, if I have to debug something, right? Let's say if I know that this particular user did not get notified for user one, site one, then how do I debug this? So on top of Elasticsearch, there is, I mean, for example, one solution is what is called as ELK stack, which is Elasticsearch with Kibana. So Kibana is a tool that helps you visualize whatever is there on Elasticsearch, the logs that are there on Elasticsearch, right? So there you could search for, if I have all the information indexed on Elasticsearch, And if I have Kibana as a tool to query and visualize on Kibana, so in Kibana I can search for, firstly, hey, show me which log had user one and site one in it, right? So I can search for user one, site one. It might show me some logs with a trace ID. So that way I know which trace ID am I looking for. So I'll get a trace ID. Then I can search in the same Kibana for this trace ID, and it will show me all the logs that I have for this trace ID. And I can see which logs are missing, which log should be there, but it isn't there. And that will show me where the drop happened. Maybe it happened here. I mean, all of the expected steps have happened, but here this particular step did not happen. And maybe hence this is where the problem might be. This kind of a system that exists that helps you trace things all across is observability. There's another thing called as monitoring, which is monitoring and alerts, which is for all components that you have, which is, let's say, these machines, your database machines, what is their CPU, what is their storage, tracking that all the time and raising alert if something unexpected happens. That is monitoring and alerting. Does that make sense, folks? Look, again, I'm just telling you that this is a concept that you have to understand. Now, to implement the concept, you could have different softwares. I've used Elasticsearch and Kibana. You could use something else, right? Uh, I understand, Vishal, there is so much to take, but I hope, I mean, this is at least getting you started, right? Now, when you go and read about Elasticsearch and Kibana, it will make more sense to you. It will strike you quickly. You'll learn quickly. That's where I'm just trying to get you to. Finally, Docker. How many of you have heard about this statement? It works on my laptop, but it is not working there. A lot of people say, but it works on my machine. It works on my machine, but it's not working there, right? And it typically happens because it is possible. Yeah, it's a popular meme, correct, right? It's possible that I wrote a code on one machine which had some configuration set, right? Maybe it was running Ubuntu, maybe it was running a Python version 2. Sorry, Python version 3.1, maybe running some other things as well, right? Now when I wrote my code here, it seems to work. When I go to another, I put my code on a production machine. This is a machine where it is going to eventually run. If this machine has a different setting, let's say it is running a different OS, let's say this is running OpenSUSE or Fedora. Let's just use Fedora. Fedora is more known, right? It's running maybe Fedora, maybe it's running a different Python version. It's running Python 3.5 and a few other things are different here, right? It is possible then that the code you have here, when it's put in a different environment, it doesn't behave the exact same way, right? And that is bad. You don't want that developers are having to say that, oh, it works on my machine but it doesn't work there. You want that if something works here, it's been tested properly, then it works there as well, exactly in the same setup, right? It could be because of anything, right? It could be because of system variable, it could be because of the operating system, could be because of the Python version. You never know, because some things might behave differently based on the version, correct? So how do I fix it? So one way of fixing this is to say that, look, I mean, when I'm going and renting machine from Amazon, I have the full flexibility of telling Amazon what kind of machines do I want. I can maybe also tell Amazon that here are 10 things that I want in the environment, right? I want, because if all of my developers are working on Ubuntu, then maybe all of these machines should also have Ubuntu. Maybe they all should have Python 3.1. Maybe you should have the same exact system variables, right? And that's why Docker came into place. Docker said, I will make this process super simple for you. There is a Docker file. You tell me what you want. You tell me what OS do you want. You tell me what Python version do you want. You tell me what libraries you want installed. You just write one line for everything. And all you have to do is on this machine that you rent from Amazon, you put this Docker file, you run this, you run a setup. I mean, Docker is nothing but like just a container. So in this machine, everything is going to run inside a container, and container is going to have exactly all of these setup. Now, when you run a code, it is running in exactly the same environment that you had on your machine. And hence, the phenomenon of it was working on my machine but it is not working there should not happen, or it reduces significantly. The probability of that happening reduces significantly. So Docker, yes, Neha, you're very right. Actually, Docker is sort of like a virtual machine. It's sort of like a virtual machine where you're able to define what exact configs do you need. Is Docker dead now? Different container engines are better. Very hard for me to say. Um, Docker is still, I mean, in terms of distribution, is still very popular. A lot of websites, a lot of companies still use Docker. So um, hard for me to say that Docker is dead. I can't declare that Docker is dead in that case. So exporting Docker is super simple, Vignesh. Docker is defined by the Docker file, right? Which is just like a config file. All you need to do is you need to port over, I mean, just copy that file to a different machine, run that file, and you'll have a different container with the same setup. If you have to orchestrate across multiple machines, then you use Kubernetes. But to be honest, to explain Kubernetes, it will take more time for me. We're already at the end of the session. I know that there is so much to cover in cloud computing, but I also have to be cognizant of time. Um, but I'll summarize. I understand that like this was a lot to take. There was so much to cover, but I will summarize. In general, the reason why cloud computing systems were born is because maintaining your own machines, maintaining I mean, your own load balancer, your own Elasticsearch, your own Kafka, your own NoSQL DB, your own SQL DB, etc., is super cumbersome. If everybody has to make their own thing, then building a software becomes extremely hard. Hence, a lot of companies said, why don't we maintain these machines for you? We will build these systems for you. All you have to do is you have to rent these systems from us. All you have to do is you have to rent these. And that's the origin of cloud. Cloud has nothing to do with the cloud in the skies. Cloud is just a collection of machines which you can rent from. To be able to facilitate all kinds of renting of all kinds of configuration, there are virtual machines. Hence came the concept of virtual machine, so that you can facilitate this part, right? You can give people configured set of machines that they are comfortable renting out. Cloud is just someone else's computer. Yes. Someone else's computer. Yes. However, what is the right way to learn cloud? The common mistake people do is they open up AWS console, they start going over what does AWS have. Look, that's the, if you start from there, you'll always be very lost, because you'll be learning, I mean, there's so many things, you'll be learning new things every single day. You would not understand when to use this versus that. The right way to learn cloud is you first start with system design. You understand what does it take to build a system, right? When do you use Elasticsearch versus when do I use, let's say, a NoSQL DB? Within NoSQL DB as well, when should I use a MongoDB versus when should I use a DynamoDB versus when should I use a Cassandra? Understanding that is more important, right? When should I use an object storage? When do I use CDN? That is more important. Obviously, what I have covered here is a subset of the um, overall knowledge that you would need. But what I hope is, I mean, the what I wanted to do through this class was get you started on the process, which means now tomorrow, if you want to learn about some of this, you have a good intro or good um, starting point to start from. Some of the things will start making more sense to you now when you go and read an article, now when you go and watch a YouTube video. It should make more sense to you, right? So that was the purpose of today's class. I hope some of it made sense. um, the purpose of today's class was not that you end up going back learning all about Elasticsearch, Kafka, etc. To be honest, while I would love to do that, it is impossible to do inside a single sitting of a session. So this was an introduction to cloud. I hope this gets all of you started on that journey to learn about these systems. If ever you build a large system, in fact, even a small system, chances are you're going to, you know, use cloud. So, I mean, good to learn about cloud. It's not just for your job, but even for things that you'll build in the future. What I do as a process is I also do a poll to typically get feedback about myself, what I can do to improve. Um, One thing that I want to apologize for is that, look, we had a very differing crowd today, right? Some people were extreme beginners versus some people were very advanced. While I tried to take everybody along, I'm sure like some of you might not have been super happy. So I apologize for those of you who were not super happy. But what we'll do is we'll do a few polls to understand what I could have done better. So we've launched the first poll, which is if you have any feedback from me, you can, by the way, also share it with me later on. What I'll also do is this script or notes that you see here, we will upload that in the WhatsApp groups and the Telegram groups that you might be part of. So look forward to that. I mean, you'll get that once the session is over. Few more
Yes,
advice points that I have for you. Sorry, Devanshu, I'm just
no
so sorry.
problem.
Just
Yes, yes, no.
few more advice points that I have. As you get started on your journey to learn system design, there are a few things you should keep in mind. One is if you're looking for books, there is a very good book called as Designing Data Intensive Applications. So if you can buy that book, please do so. I have nothing that I gain from you buying the book, by the way. I'm just recommending it because I like that book. Or you can also look at there's a website called as Byte Go. So you can look at that website as well. Both are good. Few more things there. However, when you read something and as you start learning about some of the system design components, it is very, very important that you also practice. What I mean by that is take a system, and try to design it, some part of that system, right? For example, let's say you take Flipkart or you take Amazon, Amazon e-commerce, right? And you try to design one component of that yourself. As you design it, if you have somebody senior in your life, try to get feedback from them what you could have done better, what are the cases that you have missed, where have you made mistakes, where have you chosen the wrong component, and why so. Try to get that feedback, because the first rule of learning is you learn by making mistakes. If you run away from mistakes, you will not learn. The more mistakes you make, the quicker you learn, right? So these resources plus get feedback. The more feedback you get, the quicker you learn. All of this is, by the way, there at Scalar. If you come to Scalar, then there is structured content, plus you also have mentors who take your mock interviews, so you get feedback from them. um, but in spite of Scalar, whether or not you come to Scalar, when you do prepare on your own, please make sure you look at getting feedback. That is what is going to help you learn. All right. Yeah, I mean, yes, I mean, so Scalar's program has system design as part of the program, right? The Scalar Academy program that we have. With that, I will take your leave. I'll obviously share the notes with you. Um, Devanshi, over to you to maybe answer some of the questions, because there are some questions around certificates. Um, some questions around WhatsApp groups. Maybe you can answer
Yeah,
those questions
no
for people.
problem. I'll take that over. Thank you so much for such a wonderful session. And yes, hoping to see you all in the next session. I am going to pin that link again if you have forgotten to register for the session. It's a free class where you'll get a lot of insights on how to ace top tech interviews. So I'm going to pin it for you guys again. Please register for this class and join with us for this class. I will take up a couple of questions from the questions tab before we end today's session. A lot of y'all have questions about the certificates and the notes and the recording. So again, just to repeat myself, the recording is not available for everybody. It is only available for the people who are a part of Scalar community or who are the paid learners.